FluoRender tutorials. Benchmarking the graphics system. Part 1. Commands. The latest versions of FluoRender support several command line options. Open a command line window and type FluoRender. Press Enter to start FluoRender in default settings. To start FluoRender with all panels hidden, add the command HP. Press Enter to start FluoRender. The HP option is equivalent to clicking the Hide UI button. To start FluoRender in a non-maximized window, use the option Win. Now, FluoRender's main window is not maximized. To specify the window size, use the commands W and H. For example, we'd like a window of 1600 pixels wide and 900 pixels high. You need to type values smaller than your actual display resolution. Then, FluoRender will start with the specified window size. You can add file names to load them into FluoRender automatically. Notice that multiple files and options are supported. Separate file names and options with spaces. The command F starts FluoRender in full screen mode. You can start in full screen mode and load a dataset. This is equivalent to clicking the full screen mode button in FluoRender. Press the ESC key on keyboard to quit the full screen mode. The next option is B for benchmarking the rendering speed. FluoRender refreshes the render view as fast as possible in the benchmark. A real-time FPS number is shown on the title bar. An overall rendering speed is shown when FluoRender is closed. We also provide several benchmark files in the Data directory. The first file is a large grid image to test the rendering resolution. When this image is resampled, the lines may disappear or become blurry. Load this image file into FluoRender using the command line. Click the 1:1 button to render the image at its full resolution. Move the image and make sure all grid lines can be rendered. If it is rendered correctly, it means large datasets can be handled. You can send us your system information if it doesn't render. It will help us diagnose the rendering problem and fix it. Finally, we provide 2 batch files for standard speed tests. One for benchmarking in a maximized window. It contains the commands B and HP and loads 3 channels of data. Another adds the F command to run the test in full screen mode. Let's try them on the system. It's a Windows 7 system with an nvidia Quadro M6000 graphics card. The display resolution is set to 1920 by 1080 at 60 Hz. This computer is mainly used for developing FluoRender. It has a relatively fast rendering speed at over 18 FPS. Let's keep the benchmark running for about a half minute. When we close FluoRender, the overall FPS is 18.60. We will put down the score and compare with other systems. Now, let's run the full screen benchmark. You will see a still image, although FluoRender keeps refreshing it. Don't rotate or move the rendered image. Notice that we are using the default volume properties. You may change the default settings, such as the sample value. However, the benchmark result may be influenced. Let's press the Escape key to end benchmarking. The overall FPS is 11.69, which is lower than the windowed mode. This is because of the increased rendering area. Part 2. Benchmarking on Apple computers. The same benchmark functions are available for Mac OS as well. You need to browse inside the FluoRender app folder. In the Mac OS folder, 2 shell script files are provided. Click the shell script file to start FluoRender benchmarking. It starts FluoRender and loads the sample data automatically. A real-time FPS reading can be found on the title bar. The FPS reading is above 5. An overall FPS is shown to be 5.69 after FluoRender is closed. Similarly, the benchmark can be run in the full screen mode. This is an iMac 27-inch, which is used for FluoRender Mac development. We also set the display resolution to 1920 by 1080 at 60 Hz. The rendering speed is low because it has a laptop graphics card. Press the Escape key to end benchmarking and the FPS is 3.78. As expected, the full screen rendering is slower than the windowed mode. Windows 10 is installed on boot camp of the same iMac. Let's run the same benchmarks on Windows. In the windowed mode, the real-time FPS is about the same. Let's keep the benchmark running for about a half minute. Theoretically, we should get the identical scores as on Mac OS, because we are using the same graphics card to render the data. When we close FluoRender, the overall FPS is 5.81. Now, let's benchmark it in the full screen mode. The full screen mode is better for benchmarking because it is less influenced by the user interface elements. However, it is also good to make sure no background programs are running. When we stop FluoRender, the FPS reading is 3.44. Both benchmark scores are similar to those on Mac OS. Part 3. Benchmarking on AMD Radeon Pro Duo. It would be interesting to see benchmark results on a dual GPU card. We are using a FluoRender test system. It has an AMD Radeon Pro Duo graphics card with 2 Fiji GPUs. The windowed mode can only utilize a single GPU. The rendering speed is at over 22 FPS. The graphics card is high-end for video games. Let's run the benchmark for about a half minute. When we close FluoRender, the overall FPS is 22.51, depending on the AMD CrossFire configurations. The full screen rendering can be quite different for this graphics card. Let's open AMD Radeon settings and go to the FluoRender settings. First, we set the CrossFire mode to disabled and run the benchmark. Now, only one GPU is used for rendering. We would expect a lower FPS number than 22. Let's keep the benchmark running for about a half minute. When we stop the benchmark, the overall FPS is 14.14. Go back to the AMD Radeon settings. Set FluoRender's CrossFire mode to AFR friendly. Then, run the full screen benchmark again. AFR stands for alternate frame rendering. Two GPUs are rendering 2 consecutive frames simultaneously. Rendering speed can then be doubled. It works only in the full screen mode for this graphics card. Because most video games are run in the full screen mode. Let's run the benchmark for about a half minute. The overall FPS is 27.55, almost doubled indeed and faster than windowed. Let's also look at the power consumption of this system. We are using a power meter program by Thermaltake. The diagram shows that it uses less than 150 watts on idle. The power goes to about 300 watts when one GPU is used. And the consumption can go over 550 watts when both GPUs are used. Part 4. Benchmarking on two AMD FirePro W7100s. We have another test system with two AMD FirePro graphics cards. We first benchmark with the CrossFire set to disabled. Run the windowed benchmark with the batch file. The system is installed with Windows 7. The two identical graphics cards are AMD FirePro W7100. When CrossFire is disabled, only one graphics card is used for rendering. The FirePro W7100 is a mid-range professional graphics card. It has a moderate rendering speed at over 10 FPS. The overall FPS is 11.01 for one card in window mode. Then, we run the full screen benchmark. Still one graphics card is used for rendering. As usual, we would expect a lower FPS in the full screen mode. Let's still run the benchmark for about a half minute. The overall FPS is 6.90 for the full screen mode with one card. Now, let's set the CrossFire mode to AFR friendly for FluoRender. We're on both the windowed and full screen benchmarks again. And see if both graphics cards can be really utilized. In the windowed mode, we see that the FPS increases to about 19. The professional cards allow CrossFire rendering for windowed programs. This is because most professional programs are in windowed mode. The combined rendering speed of two W7100s is similar to one Quadro M6000. This can be considered as a more economical solution. The overall FPS for two W7100s is 18.96. Finally, we benchmark it in the full screen mode. It should utilize two graphics cards as well. Another benefit of using professional graphics cards is 10-bit support. The current benchmark is actually run and recorded in 10-bit RGB format. A finer color gradation is available in the 10-bit mode. You will also need a 10-bit LCD panel to use the 10-bit mode. These features are so far unavailable on gaming graphics cards. The overall FPS is 12.82 when both cards are used. It is actually a little faster than a single Quadro M6000. Here are the results for the benchmarks in window mode. The lowest is the iMac 27-inch, and then a single FirePro W7100, the Quadro M6000, and then two FirePro W7100s. The Radeon Pro Duo with single GPU is the fastest. In the full screen mode, the iMac 27-inch is the slowest, and then a single FirePro, the Quadro M6000, two FirePros. The Radeon Pro Duo is still faster with a single GPU. Its CrossFire mode almost doubles the rendering speed.